going to start taking a look at the different types of events, which are also going to govern our different probability rules. In the last video, we just took a look at the most elementary types of probability. So the first thing that we have to do is we have to be able to identify different types of events. If two events cannot happen at the same time, that's called disjoint events. All right? And I'll give you an example of two events that are disjoint. One example would be alive and dead at the same time. Okay? Although sometimes in statistics you might feel like you're both alive and dead, I assure you that they are disjoint events. Another example would be that you are present for class and not present for class. Rich, monetarily rich, and poor. All right. So those are just three examples of disjoint events. Now, two events that could occur at the same time, but they don't affect each other's probabilities, are going to be called independent. So independent events, again, they could occur at the same time. All right. So just some examples of things that are independent. For example, it is sunny and Tuesday. So the weather really doesn't care what day it is. It's going to be sunny if the weather decides it's going to be sunny. It's going to be rainy if the weather decides to be rainy. All right. Another example of independent events is that I drive a, I don't know, I drive a Jeep and I wear, I don't know, yellow shirt. All right. So usually the type of car that you drive does not indicate what type of color shirt you wear. All right. You're going to wear whatever shirt you want and you're going to drive whatever car you want. All right. So maybe you have a favorite color, but everybody's got a favorite color. They'll all balance out. All right. So those are examples of independent events. And then the last type of event that we have are the ones to where they could occur at the same time, and they affect each other's probabilities. All right. So that's going to be called conditional. All right. So conditional events are events where they do affect one another. And just some examples of conditional events: cold outside and wear a coat. All right. You're much more likely to wear a coat if it's cold outside. Another example of conditional event might be if you draw an ace from a deck of cards and then without replacement, draw another ace. Right? So, and you know that once you draw an ace from a deck, there's only three in a standard deck. There's only three aces left, which means that you have a significantly lower probability of pulling out another ace in succession. All right, so conditional means that basically something else is occurring to affect the probability. All right, so first thing we'd have to do is we'd have to identify what types of events that we're looking at. And then once we do that, then we can start implementing these rules of probability. So the rules are as follows, and there's only 4 of them. And the good news is of the 4, we've already done 1 of them. If 2 events are disjoint, which means that they can't occur at the same time, then their probability is found just by adding the sum of the probabilities. And we already did this earlier. You might remember in the first video we had this contingency table. Remember one of the questions we answered was, what's the probability that somebody smokes casually? And so what we did was we added 15 and 13, we got 28. But in reality, we had 15 out of 288 and 13 out of 288. And we just added those together. And that gave us the 28 out of 288. And that's what we mean by using the disjoint problem. Same thing with letter D, where we added all the females together, and we ended up with a probability of just females because it's independent that somebody smokes often, smokes casually, does not smoke. It has to be one of the 3. You can't fit into all 3 categories. You can't fit into 2 categories. Okay, so the respondents only apply to 1 category. That's what we mean by disjoint. Another rule is independence, and these three are mainly going to be independence. So if A and B are independent, the probability of both of them occurring at the same time is the product. So in other words, we just multiply probability of A times probability of B. If A and B are independent events, the probability of A or B occurring. Right? So we have these key words. So we have and we have or. Right? So we're going to keep those in mind when we start doing some problem solving. Then the probability is going to be the sum of the probabilities minus the product of the probabilities. And I'll draw a picture in a moment to help you understand why we subtract out the intersection and why we don't subtract the intersection up here. Wouldn't it make sense that we would just subtract the intersection for disjoint events as well as independent? And finally, if we want to know the probability that event does not occur, it's called the complement. We just subtract 1, or we just subtract that probability from 1. All right, so just an idea of kind of what these look like, right? So that way you can kind of fit these in together in your head with a picture. If the events are disjoint, then this is what they look like. So we have event A and we have event B, all right? And we have a total sample space where the probability is 1. So if I want to know the probability of A or B occurring, I just add these together. Now, what about independent events? Well, with independent, there could be an overlap. And let's just assume that there is. So with independent events, let's say this is A and this is B. And right here is the intersection. Let's just say that's A and B. And that's found by A times B. But what we really want is we want the probability of A or B. So what we really want is we want this probability, which is A, or this probability, which is the probability of B, but not at the same time of A or B. So we have P of A, we have P of B, and we're going to add those together, but then we're going to subtract out the probability of A times B. That's the middle stuff there. So we don't want the middle, which is why we need this subtraction part of the formula. All right, so hopefully that helps you to understand why we subtract those out. All right, so the last 2 videos, all we're going to do is we're just going to use these formulas to be able to solve problems related to independent events.